All right, good evening. So we start slowly while we are waiting for the others to come in. Okay, so today we are just focusing on scheduling algorithm because I have posted your assignment one. So you need to know this one before you can do your assignment. All right, so in your assignment as well, you have first come, first serve, shortest job first, round robin, and priority scheduling. All right. So we are going to go one by one. All right. Okay. So first come, first serve, it says that process that request the CPU first is allocated the CPU first, also called first in, first out. All right. So I believe you know this. Implementations, first in, first out queue. A new process enters the tail of the queue. Okay. So proses yang baru masuk, dia akan beratur di ekor barisan. Okay, tail, ekor barisan. Maksudnya siapa yang baru masuk, dia akan beratur di belakang barisan. Alright. The scheduler select the process at the head of the queue. Maksudnya siapa yang ada di depan akan dijalankan dulu. So this process will be like you are going to the shopping complex. Alright. Maksudnya bila kamu nak bayar, siapa yang nak datang dulu, dia akan bayar dulu. Alright. So I give you the example of shopping mall, or when you go to any shop, when you want to shop for groceries. So those who come in first will be going to serve first, and then those come out later will queue behind the queue. All right. Okay. So this is the simpler one with no arrival time. Later we are going to look into the one with arrival time. Okay, so you have three processes, P1, P2, and P3. With the durations of P1 equals to 24, P2 equals to 3, P3 equals to 4. All right. So it comes in order of P1 come first, followed by P2, and followed by P3. So in this case, we are not going to consider any inter-arrival time. Arrival time over here, we are not considering. Later, you are going to see an example of arrival time. Okay. So first come, first serve will be quite simple. So you see, when time 0, so it will going to execute P1, which is in the first order. Okay, until 24, it finished. All right. So follow my P2. So P2 is 3 units. So when you start from 24, after 3 units will be 27. All right. So followed by P3, you have 4 units. So after 27, 4 units will be equals to berapa? 31. So 0, 24, 27, 31. All right. Okay. So it says that P1 masuk-masuk dia saja, dia dah masuk. So dia tak ada waiting time. There is no wasting of any time for P1. Whereas before P2 can go in, you see it waits for 24 seconds. All right. So that's why the waiting time for P2 is 24. Okay. So for P3, it needs to wait P1 and P2 finishes. That's why it has wait for 27 seconds before it can be executed. So overall, the waiting time, the average waiting time will be equals to 0 plus 24 plus 27 over 3 processes. That is why your average waiting time in this first come, first serve example is 17. Okay? So 1 minute for you to look into this one. It's quite simple. We are going to the second one later. right, this one quite simple, huh? All right, so then you are going to round robin. Okay, round robin is not in a, it will not be in your shopping complex, huh? If you are doing round robin inside your shopping complex, will mean that, okay, one people can pay for 4 items at one time. Okay, then if you are having more than 4 items, you need to queue second time. Okay, that is the case. All right, let us read on that. One of the oldest, simplest, most commonly used scheduler algorithm. Okay, select process or trades from ready queue in a round robin fashion. So it takes turns, it said. Okay, problems. Does not consider priority, context switch overhead. All right. Okay, before that, apa itu preemptive and apa itu non-preemptive. All right. So over here. So it says, what is difference between preemptive and non-preemptive? So it says that the key difference between preemptive and non-preemptive scheduling. In preemptive scheduling, the CPU is allocated to the processes for a limited time, whereas in non-preemptive scheduling, the CPU is allocated to the process till it's terminate or switches to the waiting stage. Alright? Yang bermaksud, kalau non-preemptive, dia akan habiskan proses, dia tak kira. Saya tak kira lah berapa lama kamu tunggu. Okay, saya nak habiskan proses saya juga. Okay, this will be like in your shopping complex, as I said. The same thing when you are going to the highway, you are going to the toilet. Okay, no, it doesn't care how much time it takes. It will be in the toilet until it finish, and then it will allows other to come out. Okay, that is non-preemptive. Whereas preemptive adalah preemptive scheduler, maksudnya dia akan membenarkan satu proses itu berada di dalam queue itu untuk certain masa yang tertentu. Alright, selepas habis certain masa itu, dia kena queue balik. That is preemptive. Okay, so round robin is a preemptive algorithm. Boleh? In your assignment, is going to ask all these questions, huh? So is it preemptive or non-preemptive? You need to answer that. All right. So okay, another 1 minute for you to read into this one. The difference between non-preemptive and preemptive. Okay. Kalau ada soalan tanya, preemptive dengan non-preemptive. Alright. So in this case, round robin should be preemptive. Maksudnya dia akan berada di dalam prosesor untuk certain masa tertentu. Kalau dia tak habis proses itu, tetapi sudah turnnya untuk keluar, it needs to go out and then it needs to go back inside the queue again. So that is round robin. Okay, so we look into the example. So this one quite simple. We look into the simple one before we go into the a bit more complex one. Okay, so it says P1, the duration is 3, P2, the duration is 4, and P3, the duration is 3. And it comes into order, P1, the first order, So followed by P2 and then followed by P3. We are not going to consider any arrival time in this case. So it said that suppose the time quantum is 1 unit. Alright, ini saya. Selepas dia menjalankan 1 unit, dia perlu keluar daripada queue and then it will allows other to go into the queue again. Okay, so let us see. So hijau adalah untuk proses 1. Merah adalah untuk proses 2. Biru adalah untuk proses 3. Okay, so bear in mind when you do this type of questions, make sure you will know how many blocks are there. Okay, kamu senang melakukan kesilapan jika kamu tidak tolak. So biasanya kalau saya selepas berjalan 1, saya akan tolak, saya akan tulis 2 kat sini. So ini selepas berjalan 1, saya akan tulis 3 kat sini. So you are not going to miss out. In this case, you have 3 processes. Okay, it's quite simple. Let's say in your questions, you have 6 processes and the duration time is different, you are going to miss out. Okay, so make sure you cancel it after you finish 1 unit. Okay, so it's supposed to be P1 you have 3 units, P2 you have 4 units, and P3 you are having 3 units. All right, so P1, P2, P3, okay, followed by P1, P2, P3, followed by P1, P2, P3. So another block of P2 haven't finished. So lastly, it will be going to be P2. All right. Okay, so we are going to look into the waiting time. Okay, P1. You see, P1 over here, it finished at 1, 2, 3, 4, 5, 6, 7. Okay, it finished at 7. Okay, it's finished at 7. 7 minus the 3 blocks. So you have 4. Again, P1, kamu kalau tengok P1 itu kamu tengok kat hijau. Okay, hijau, yang paling akhir hijau dia berhenti pada saat berapa? Saat 1, 2, 3, 4, 5, 6, 7. So dia berhenti pada saat ke-7, tolak yang dia sendiri. Tolak 3 unit dia. That is why you are having 4. Okay? So, okay. So sekarang kita tengok kat P2. Okay, P2 habis pada unit ke berapa? Okay, you say P2 finish at block 10. Okay, 10 tolak dengan dia sendiri executions, you are going to have 6. Okay, 10 tolak dengan 4, kamu dapat 6. Okay, P3 finish at second number 9 over here. 9 minus 3, you have 6. So your average waiting time will be equals to 4 plus 6 plus 6 over 3, which is equals to 5.33. Okay, I give you another 1 minute to look into this, and then I will explain another time. Okay.
Sorry, doctor. I would like to ask on that. if the is that just now doctor mentioned that the P1, right,
Hmm.
until uh until 7 second, right?
Yes.
So is it the arrival time for the process P1?
It's
Is it
not the
considered
arrival.
as
It
or
is
not
not
arrival, just something like completion time or
completion time, correct? The times is complete.
completion time?
Okay, ah.
So if arrival time is what actually?
Okay. So
If
over here you
just to
have
say
arrival.
the process,
Okay. Over
yeah,
here you have
zero, right?
arrival time of 0. Later after this, we are going to have the arrival time. Then you can see what's the difference later. Okay.
Okay, sure. Okay,
Sure.
thank you, doctor.
Okay. Let me explain another time. Okay. So in round robin, in this case, it's quite simple. You have 3 processes. With P1, the duration is 3. P2, the duration is 4. And P3, the duration is 3. So it says that you are using the quantum of 1 unit. So at one time, it can only process 1 second. All right. So you see, so P1 come in first, which is in green color, followed by P2, which is in red color, and followed by P3, which is in blue color. Okay. So after this, you will go back into the queue, P1, P2, P3. All right. So P1, P2, P3. So after this P3, P1 have finished. P2, you have another 1 unit. So you have red color. And P3 has finished as well. All right. So we are calculating on the waiting time. So the way to calculate the waiting time is that you are looking at the finish time. All right. So the finish time of P1 is 7. 7 minus itself, 3. So you are having 4. All right. P2, the finish time is 10. 10 minus itself, you have 6. All right. P3, the finish time is 9. 9 minus itself, 3. So you have 6. So the average waiting time will be equals to 4 plus 6 plus 6 over 3, which is equals to this number. All right. Okay. So 30 seconds, we will go to the another slide.
Doctor,
Yes, saya.
for the P3, how do you count the unit? How do you get
Okay,
the
P3,
timing?
how to get the time? 6, is it? Okay, you
Yeah,
see
yeah, yeah.
P3 is finished at unit 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It finished at 9. You see blue color at N at 9 seconds. Blue color, warna biru, habis pada saat ke-9. Okay, so dia habis pada saat ke-9, dia tolak dia sendiri, 3. So, 9 tolak 3, kamu dapat 6. Can you see that?
Oh, okay, okay. Thank you.
Okay, all right. So it needs time to look into that one. So perhaps another 1 minute for others to catch up everything. Okay. Ya, tak boleh record sebab saya tak guna account fakulti, saya guna account sendiri. It's okay, the slide I have been posted to the e-learning. So if you have problems again, we can discuss again. So I have set the assignment date X. If you have any problem, we can discuss on the date. Okay. So after round robin, so it tells you choosing the time quantum. So it's okay. Yeah? So time quantum, as I said, it will be the 2 to the power of x. Okay, it can be 1, it can be 2, it can be 4, it can be 8, it can be 16, it can be 32. All right. So this should be some theory. I just let it to you. Okay, shortest job first. This will be quite simple as well. So let us read together before we look into the example. It says that schedule the job with the shortest computations time first. All right. So scheduling in batch system, optimal if all jobs are available simultaneously. Give the best possible AWT, average waiting time. So it says that shortest job first has the less average waiting time. Okay, let us read together. Okay, so this is the one. So in this process, you are going to have 4 processes, P1, P2, P3, and P4 with the durations of 6, 8, 7, and 3 itself. Okay, so it says that all of these come on the time, kosong, 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 kosong. So in shortest job first, although you are giving order 1, 2, 3, 4 coming, okay, tapi dia masuk pada masa yang sama, arrival time, kosong, 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 kosong. So you are not going to consider any into the duration, which is the smallest, will go into the queue first. Okay, again. In shortest job first, although your process come in order of 1, 2, 3, 4, but you are not going to consider that because all these processes come on time of 0, 0, 0. So what we are going to consider is the durations. So the shortest durations will go into the queue first. Okay, so if you look into 6, 8, 7, 3, so the order will be from the smallest to the highest will be 3, 6, 7, 8. Okay, we arrange from the smallest to the biggest, which will be 3, 6, 7, 8. So each will mean P1, P4, P1, P3, and P2. Okay. All right. So let us look into the Gantt chart together. So P4 go into the queue, which has 3 units, followed by P1, which is 6 units. So 3 plus 6 will be equals to 9. All right. We are going to go into the P3, which is 7 units. So 9 plus 7 will be equals to 16. Okay, lastly, P2, which has 8 units. So 16 plus 8 will be equals to 24. Again, the smallest process will go into the queue first. So we are going to arrange in order of 3, 6, 7, 8, which will mean P4, P1, P3, and P2. Okay, so shortest one, P4 will be 3 units. So 0 to 3. P1, 6 units. So 3 plus 6 will be equals to 9. P3, 7 units. So 9 plus 7 will be equals to 16. P2, 8 units. So 16 plus 8 will be equals to 24 seconds. Okay. All right. So now we are looking into the waiting time. Okay. So it calculates first the P4. P4 waiting times, you see, it ends at 3. It minus itself 3. So it gets 0. All right. P1 finish at 9. Finish at 9 minus itself 6. So you have 3. All right. P3, it finished at 16 minus itself 7. So you have 9. Lastly, P2, it finished as 24 minus itself 8. You have 16. So the average waiting time will be equals to 3 plus 9 plus 16 over 4, which will be equals to 7. Again. All right. So P4 finish at 3 seconds. It minus itself 3. So you have 0. All right. P1 finish at 9 minus itself 6. So you have 3. Okay. P3 finish at 16 minus itself 7. You have 9. Lastly, P2 finish at 24 minus itself 8. So you have 16. All right. So 1 minute for you to look into this before we go to the last one is priority. Okay, boleh? So hopefully fine. So kita pergi yang the last one. Okay, dia buat comparison. So it compare the first come first serve, which is calculate the average waiting time. So it will tell you that shortest job first will have the less waiting time. Okay, tak apa, kita buat untuk first come first serve. Okay, maksudnya first come first serve. Okay, so process 1 first, 0 to 6, followed by process 2, 6 plus 8 equals to 14, followed by process 3, 14 plus 7 equals to 21, and then we have P4, which is 3, so 21 to 24. So in finding the waiting time, you see, P1 will be equals to 6 minus 6 equals to 0. For P2, 14 minus itself 8, you have 6. Okay? So P3, 21 minus itself 7, you have 14. Okay, P4, finish at 24 minus itself 3, you have 21. Okay, so the average waiting time for first come first serve will be equals to 6 plus 14 plus 21 over 4. You have 10.25. So you have more waiting time compared to shortest job first, which has only 7. Okay, again, first come first serve will have the waiting time of 10.25 comparing to first shortest job first, you have only 7. That is why it says that shortest job first has a good average waiting time, which it has less waiting time if compared to others algorithm. Okay? Boleh? So we are about to finish this one. We have another one. All right, hopefully fine. So we go to the last one, which is priority scheduling. All right, the highest priority will go into the queue first. Okay, so it gives you 5 processes which are P1, P2, P3, P4, P5 with the durations of 10, 1, 2, 1, 5. Okay, so when priority scheduling is going to give you the priority, so you need to follow the highest priority to the lowest priority. So you are going to go 5, 4, 3, 2, 1, which will be P4, P3, P1, P5, and P2. All right. So firstly, P4, sorry, yes, P4. Okay, highest priority. It arranged in 1, 2, 3, 4, 5. Huh? I get it wrong. Okay. Highest priority is going to have first priority, second priority, third priority, fourth priority, and fifth priority. Okay. So it's going to go into P2, P5, P1, P3, and P4. Okay. So P2, 1 unit. All right. P5, 5 unit. P1, 10 unit. P3, 2 unit. And P4, lastly, 1 unit. Okay. So after 1 unit, you have 1. Plus 5 unit, you have 6. Plus 10 unit, you have 16. Plus 2 units, you have 18. Plus another 1 unit, you have 19. All right. So the waiting time for P1 will be P1 finish at 16. Okay, P1 finish at 16 minus itself 10, you have 6. All right. P2 finish at 1 minus itself 1, you have 0. P3 finish at 18 minus itself 2, you have 16. P4 finish at 19 minus itself 1, you have 18. Lastly, P5 finish at 6 minus itself 5, you have 1. So your average waiting time will be equals to 6 plus 16 plus 18 plus 105 will be equals to 5.2. So my dear student, are you doing fine?
Yes, madam.
Boleh ah? Alright. So I give you 1 to 2 minutes for you to refresh before we go to another slide, okay? The slide you can get on your e-learning. All right, so it say these are the scheduling you have: first come first serve, shorter job next, priority, Okay, so shortest remaining we are not going to discuss. So round robin. So it explained to you what is non-preemptive and preemptive. All right, so we have discussed that before. Okay, so we are going to first come, first serve, or first in, first out with arrival time. Okay, means that at 0 second, you have only P not inside the queue. At 1 second, you have P naught and P2, P naught and P1. At 2 seconds, you have P naught, P1, and P2. So at 3 seconds, you have P naught, P1, P2, and P3. All right. So you say that the durations for P naught is 5. Durations for P1 is 3. Durations for P2 is 8. Okay, durations for P3 will be equals to 6. Okay, so you don't care about this one first. This one is the end time. Later you are going to get from your Gantt chart. So it says at 0 second, only P naught. So it ran P naught 5 units. Okay, so at 1 second, P1 come in, but P1 cannot be executed because P naught is inside the queue. So by the time P naught have finished by 5 seconds, P1, P2, P3 already inside the queue. Okay. Although P1, P2, and P3 already inside the queue, but we are going to execute P1 first. Why? Okay, why? Okay, dia contohnya macam kamu pergi ke grocery store. Okay, any grocery store. When you go to grocery store, pada saat kosong, orang kosong ini masuk. Okay, kamu kena tunggu dia bayar walaupun kamu berada dalam queue pada saat pertama. Dia belum habis lagi sebab dia nak jalan 5. Okay, lepas tu P1 masuk. Lepas tu P2 masuk, dia akan ada kat belakang P1. Okay, selepas tu P3 masuk, dia akan berada di belakang P2. Sebab dia masuk pada saat ketiga. Alright, so in first come first serve, it may be quite simple, it's okay. But it is going to be a bit more complex when it comes to round robin later. So this one will be a bit simple, which you see at second, tak ada siapa-siapa, cuma P naught ini ada. So P naught ini akan berjalan 5 saat. So walaupun P1 ini dia sampai pada saat 1, P2 sampai pada saat 2, P3 sampai pada saat 3, tetapi dia masih perlu menunggu P0 ini habis pada saat kelima. So kenapa kita tak pergi ke P3? Sebab you see, siapa datang dulu, siapa masuk dulu. Okay, that's the means of first come, first serve. Okay, imagine, okay, siapa datang untuk kalau kamu pergi, where are you going? You are going to Simat, let's say, you are going to Simat. Okay, although all these are inside the queue, tapi P1 masuk queue dulu, followed by P2, followed by P3. So it will execute in order of P0, P1, P2, and P3. Okay. So the arrival time, the service time will be 5 plus 3 will be equals to 8 plus 8 will be equals to 16 plus another 6 will be equals to 22. Okay. So is it allows it give you the explanations of calculating the waiting time? Yes. So macam mana nak kecilkan sikit supaya nampak? Okay. Okay, hopefully you can view it well. Hopefully you can view it well. Okay, P naught. So the service time will be equals to 0 because 5 minus its arrival time. So it's equals to 0. Sorry. 5 minus 5. So it will be equals to 0 minus 0 is equals to 0. Okay. So P1 will be equals to 5 minus its arrival time, which is 1. So you see, you need to, in this case, you need to jot down the service time over here. So you see, P0 masuk pada saat ke 0, P1 masuk pada saat 5, P2 masuk pada saat 8, P3 masuk pada saat ke 16. Alright, so the waiting time will be equals to 0 minus 0, 5 minus 1, 8 minus 2, and 16 minus 3. So this will be a bit more complex compared to non-inter-arrival time. Tak ada inter-arrival time. I repeat. Okay, selepas kamu habis gancat ini, kamu perlu catat masa dia masuk ke queue. Okay, so P0 masuk ke queue saat ke 0, P1 masuk ke queue saat 5, P2 masuk ke queue saat ke 8, P3 masuk ke queue saat ke 16. So the waiting time will be equals to 0 tolak 0, 5 tolak 1, 8 tolak 2 sama dengan 6, 16 tolak 3, kamu dapat 13. So the average time, you just add it together minus the 4 processes, you get this one. Ada soalan? Can you get it? We try to finish by 9:15, it's possible. You see it quite easy now. When you do the questions, you are going to confuse. Kamu nampak dia agak simple. Tapi bila kamu buat assignment nanti, berhati-hati, okay? Be a bit more cautious because you may do mistakes. Okay? So first come, first serve, dia masih senang. It comes to a bit more challenging when you do round robin later. Okay? So another 1 minute, perhaps, we will go to the second one. Okay? Okay, shortest job first. Okay, you know the explanation. So I'm not going to into the explanations. So in this case, you have arrival time of 0, 1, 2, and 3. And the service time is the same. Is it the same? 5, 3, 8, 6. Okay. Kamu ada execution time yang sama. Okay. So in this case, you cannot go to the shortest one first, which is 3. Okay, these questions is do some mistakes. You should be doing P0 first because P1 is not inside the queue when you are having 0 second. Okay, P0 first sebab pada saat kosong bila tak ada apa-apa, P1 belum masuk. So you need to do P0 first. Alright. So this slide may be having some problem. So P0 dulu ikut. Okay, P0 maksudnya dia akan berjalan 0, hingga 5 saat. Okay. Then after P0, it will find the shortest one, which is P1, 3. Okay. Then it finds P3, which is 6. And then the last one, P2, which is 8. Okay. Again, ada some problem, ada some mistake. Ada some mistake over here. You should be doing P0 first because P0 come into the queue at 0 second. P1 masih belum masuk dalam queue. You see, P1 berada dalam queue 1 saat. So, dia tidak mungkin dijalankan pada saat yang kosong. Can you, my dear students? Again, P1 cannot be executed at time 0 because P1 is not inside the queue at 0 second. So in this case, it do some mistake. P0 should come into the queue although it is longer than P1. Okay, so this should be P0, this should be P1, this should be 5 seconds. Okay, this should be 5 seconds. So 5 minus 0 equals to 5. So 8 minus 5 equals to 3. All right, so the rest 16 minus 2 equals to 14. 8 minus 3 equals to 5 is correct. Again, P0 will be equals to 5, will be equals to 0 minus 0 equals to 0. P0 will be equals to 0 minus 0 equals to 0. P1 will be equals to 5 minus 0 equals to 5. Again, kesalahannya P0 sama dengan kosong tolak kosong sama dengan kosong. P1 sama dengan 5 tolak kosong sama dengan 5. Okay? Is it 5? Yes. Alright. So there are a mistake over here. Can you? Atau dah confused habis? Alright, we go to the next one, priority scheduling. Okay, we are not going to explain what is priority later. So over here, the highest priority will go first. So in this case, you see you have two same priority, 1, 1. Okay, when you have 1, 1, you are going to look into the arrival time. Okay. This is fine. So the priority in over here is 3, 2, 1. Tadi dia 1, 2, 3, 4, 5. Over here dia punya priority 3, 2, 1. So in the real cases, the priority should be highest 5, 4, 3, 2, 1. So in this case, you see, highest followed by 2, followed by 1. Is it? But you see, there, okay. This slide is having a problem again because you see C3, P3 is inside the queue at 3 seconds. So you cannot perform P3 first. Okay? Okay, problem kat sini. Okay, we go to round robin because I just having that. Okay. Round robin scheduling. Okay, in round robin, okay, let me see how I page. how to put 2 page. Okay, can you just memorize the one? Means that you are going to use the same table for round robin. P0, P1, P2, P3, arrival time of 0, 1, 2, 3, and the execution time of 5, 3, 8, and 6. Okay, you see round robin? You see round robin? So it say it's a quantum of 3. Again, it is doing some things you were not having a quantum of 3. It's okay, quantum of 3. Okay, so you run P0 first because P0 comes into the queue first. All right. So when you finish P0, you are running P1 because P1s come in the queue at 1 second. And then you do P2, it comes into the queue at 2 seconds. And P3, it comes into the queue at 12 seconds, 3 seconds. So P0, P1, P2, P3, you have 12. Okay, then it will turn back to P0. Okay, P0 haven't finished because P0 you are having 5 units. So it will execute another 2 units will be equals to 14. All right. So it's going to execute another 3 units of P2. Okay, 17. And then another 3 units of P3 will be equals to 20. And lastly, the rest of P2, you have another 2 units. Okay. So you are going to run the waiting time for round robin. Okay. So the same thing when you are looking into the waiting time, 8.5 for round robin, 6.5 for priority. Okay. 5.5 for shortest job first. Okay. And 5.75 for first come first serve. So shortest job first will be having the less waiting time compared to others processes. Okay? Ada soalan? Do you need me to explain again on round robin? Let me see, is it any possibility for me to put in a view of 2 pages at one time?
Need, madam, can you explain again?
Okay, okay, come. Okay, so this is the table. Okay, you are using this table for round robin. Okay, you are using this table for round robin. All right. So P0 come in at 0 second, followed by P1 at 1 second, P2 at 2 seconds, and P3 at 3 seconds. Okay. So at time 0, no one inside the queue. Only P0 inside the queue. So P0 will be run first. 3 quantum. Okay, a quantum of 3. All right. Then after P0 finish, the same thing happens when you go into the shopping complex. You have P1 come in. So maksudnya P1 akan dijalankan dulu. Okay. Tetapi dia tidak akan dia akan jalan habis untuk P1 sebab P1 3 unit aja. Okay, and then it's go to P2 3 unit. Okay, 3 unit jadi 9. Alright, so P2 selepas habis 3 unit dia masih ada 5. Dia masih ada 5. Okay, P3 akan berjalan 3 unit. Selepas berjalan 3 unit, dia masih ada 3. Okay? So, it follows the flow of P0. Dia tak berjalan P1 sebab P1 sudah habis. Okay? Then dia berjalan P3. Dan selepas semua habis, P2 masih belum habis sebab P2 ada 8 unit. Okay, I make another way. I make it another way, okay? Supaya kamu boleh faham. Okay, jika dalam proses ini kamu cuba tambah P0 kat sini 3 unit, 2 unit, kamu akan dapat 5, nampak? P1 3 unit. Satu aja. So kamu dapat 3 unit. P2 3 unit. Tambah 3 unit. Tambah 2 unit. So kamu dapat 8 unit. Lastly P3 3 unit. 3 unit. Kamu dapat 6 unit. So that is the simplest way to explain. So I go to a bit more complex one. Okay, you see dia datang masa kosong, yang ni datang masa 1, yang ni datang masa 3, yang ni datang masa 2 dan 3, okay? So P0 masuk dulu sebab pada saat kosong tak ada siapa-siapa, cuma ada P0. So P0 akan dijalankan dulu. So sebab kuantumnya 3, so maksudnya dia akan berjalan 3. Okay. After P0, kenapa kita tidak pergi ke P2, kita pergi ke P1? Sebab saat 1, P1 dah ada di sana. Takkanlah kita nak yang belakang overtake. Tapi ada di belakang. Alright, that is the reason why P1 run first. Okay. Followed by P2, the same thing, P3 is behind P2. Okay, so P2 dulu. Then P3. Okay, until 12, I think you should be okay. Until 12, you should be okay. Okay, you see kat sini 5 unit, setelah dijalankan 3 unit, dia tinggal 2 unit. Again, 5 unit, selepas dia dijalankan 3 unit, dia tinggal 2 unit. Again, 5 unit, setelah dia dijalankan 3 unit, dia tinggal 2 unit. Alright. When it is 5, it has already executed 3 units. It left 2 units. That is why P0 dia berjalan 2 unit saja. Can you? Okay. P1 sudah berjalan 3 unit. So dia dah habis. Yeay, dia habis dah. Dia balik dah. So you cannot see P1 anymore. Okay. P2, 8 units, it will execute 3 units, it left of another 5. Okay, it left of another 5. So dia akan masukkan 3 aja sebab kuantumnya 3. That is why dia berjalan daripada 14 ke 17. Alright. So lastly P3 dia 6 unit. Dia telah menjalankan 3 unit. Dia masih ada 3 unit. That's why dia jalan 3 unit. So after that, yang P0 dah habis, P1 dah habis, yang kita tinggal adalah P2. Kita tinggal 2 unit. That is why you have 20 to 22. Can you? Boleh? So the average waiting time will be the same thing as well. You just minus, just that you need to know how the Gantt chart will be, because the Gantt chart will help you to calculate the turnaround time or the waiting time. So any questions? So can you? So it's okay today. So because we are lack of time, that is why I need to give you the online class today. Okay, by next week, if you have any problem, we are going to discuss in the class as well. So I'm giving you the durations of 2 weeks for the assignment. So by next week, we still can discuss in the class. So you try to do the questions. If have anything, we will discuss together in the class. Okay? Ada soalan? So today the main purpose is for this scheduling, because if I did not do the class, I cannot give you the assignment. Okay. So week 3, you need to have one assignment. So the assignment you can find in your e-learning as well. Will you need me to upload to WhatsApp? Sebab I believe ada yang susah nak access e-learning. You need me to send through WhatsApp as well? Yes, okay, I send you through WhatsApp as well. Later, after finish the class. So is it okay? You do the assignment? Any questions? We still can discuss in the class by Tuesday next week. I have a few videos, but the videos is all quite big, so I cannot send through e-learning. Never mind, I try to figure out what we can do. Okay, so if you don't have questions, please do the assignment and then we end our class today. Boleh? Buat assignment 10 markah. Please do your assignment. Okay, it will be contribute to 10% of your assessment. Okay, sure. Okay, so we'll see you Selasa depan 11 o'clock BK2. Okay, so I end the class. Okay, thank you.
Doctor, sorry.
Yes.
I would like to ask why the P1 process, right? Why is 3 minus 1? Suppose the service time should be 6 minus 1, right?
P3.
Yeah, because
6
refer to the
minus, yes. So this slide is having some problems. 6
okay
minus
1.
1, correct?
Okay. So
Betul?
okay. So is the
Yes, the slide having
answer wrong?
problems.
Oh, okay.
Yes.
Okay.
Okay,
Thank you. Okay. Thank you, doctor.
Okay, welcome. Alright, we'll see you Selasa depan. Thank you for having class at night. Okay?
Thank you, madam.
Thank you, Doctor.
Thank you, Doctor.
Thank you, madam.
Thank you.